Hi everyone, I hope you are well. Today's class I want to show you how to find the Jacobian matrix. Okay, we need Jacobian matrix when you want to solve nonlinear system of equation. Okay, we want to use Newton method, and to use Newton method we need Jacobian matrix. So this Jacobian matrix is the matrix of all first order partial derivatives of the vector value function. The matrix must be a squared matrix. So let's say we have a function fx. Okay, let's say for a given function, let me just write it, the Jacobian of fx, where this function is in the real space, is defined as, okay, so this is a definition for a Jacobian function or Jacobian matrix. So depends on how many dimensions here. Okay, so we can have partial f over partial x. Okay, if I have more than one dimension, I will put it like this, and then the next one will be derivative of function 1 with respect to x2, and the next one will be derivative of function 1 with respect to x3, and so on, the derivatives of function 1 with respect with xn. Now next, this is the first row of the matrix. Now second one, if we have a second function, similarly with respect to x1, the second function with respect to x2, the second function with respect to x3, and so on, the second function this should be the second function, okay? The second function with respect to x3, and so on, the second function with respect to xn. Now similarly, we can go this on and on, depends on the dimension of the system. So at the end, what you have for the n dimension of a function with respect to x1, the f of n dimension with respect to x2, partial derivative of that n function with respect to x3, and so on. Okay, so this is the big definition of the Jacobian matrix. Okay, now to understand this, what is this? What this thing means? Okay, let's look at this example. Okay, this is a very straightforward example. For instance, if I have the given function 5x1 squared minus exponent x1 x2 equals to 0, x1 x2 plus 2 cos x2 equals to 0. Now this is 2 dimension, right? So I can write this as f1, f2. So your Jacobian, okay, so the question say, write down the Jacobian for the following system, or for the given system. That's the question. What is the Jacobian for the system? Okay, so since we have 2 dimensions, so my Jacobian here, Jacobian of x1 and x2, I'm just going to write it, okay, or something like this, is given as, okay, so according to my definition, the derivative of the first function, so I'm just going to have this one, 2 by 2 dimension here, because I have function 1 and function 2. First function 1, take the derivative with respect to x1, and the first function 1, take the derivative of x2. And then move on to the second function, take the derivative with respect to x1, and take the derivative of x2, okay? So, let me just write it down. So, 2 by 2 Jacobian matrix, this is respect to x1, and then this is respect to x2. And then the second function respect to x1, and second function respect to x2. So this is my f1 and f2. Okay, so what we can do here, find the derivative of this f1 with respect to x1. So what is it? What can you get? Take the derivative of this first function just with respect to x1. So I have 10x1 here. And I have x1 here as well. So taking the derivative of exponent, x1, x2 will give you negative exponent x1, x2. Okay. Then taking the derivative of x1, x2 with respect to x1 will give me x2. So I have x2. So I have 10x1 minus x2 exponent x1, x2. Okay, so this is derivative of function 1 with respect to x1. Now, what is the derivative of the function 1 with respect to x2? Okay, look at here. Same function, my f1 here. x2 just involved here, right? So, there's nothing here. But take the derivative, I have negative exponent x1, x2. Now, if I take the derivative with respect to x2, I can get x1. So, I have negative x1 exponent x1, x2. Okay, so we have the two, the first row. From this function, the first row will be respect to function 1 respect to x1, I have 10x1 minus x2 exponent x1, x2. And then function 1 respect to x2, I have this one. Negative x1 exponent x1, x2. Okay, this is my first row. For the function f1, you take the derivative with respect to x1 for the first column. And then for the second column, the function f1, you take the derivative with respect to x2. Now let's move on to the second function here. Okay, let's move on to the second function. This one now. Okay, maybe we can do it directly on this thing here. Okay, so let's look at it again. Function 2, I'm looking at function 2 now. Respect to x1, okay. We have x1 here. That's it. So x1, x2, if you take the derivative with respect to x1, will give you x2. Okay, that's easy. That will be my the second row, first column. Okay. Now taking the derivative of f2 with respect to x2, I have here and here. Okay, taking the derivative with respect to x2 will give me x1 for this term here, and then plus 2 cos x2, that will give me negative 2 sine x2. The derivative of cos will give me negative sign. Okay, we have a constant here. So this is the Jacobian for the given function, two-dimension function. Okay, let's try one more example since we have time. Okay, the next example is, okay, we still want to just learn how to find the derivative. Okay, let's do this. 4x1 squared minus 15x1 plus x2 squared plus 8x3 equals to 0. 1 over 4 x1 x2 squared x3 plus 2x3 cubed plus 8 x1 x2 x3 equals to 0. x1 squared x3 plus 8 x2 x3 squared minus 3 cos x1 x2 equals to 0. Wow. Okay, look at this. I made this up. I'm not even sure you can ever solve this three-dimensional system, but we can see that we have variable x1, x2, x3, and it's 3-dimension, right? So your Jacobian will be a 3 by 3 matrix. Okay, the Jacobian, it must be a square matrix. Okay, Jacobian must be a square matrix. Okay, now let's see how we can write the matrix first. Okay, so obviously we have function 1, function 2, and function 3. Okay, so my sketch of my Jacobian, we have x1, x2, x3 here. There's going to be a big matrix 3 by 3. So I have first function 1 with respect to x1, function 1 with respect to x2, function 1 with respect to x3. Okay, and then the next one, function 2 with respect to x1, function 2 with respect to x2, function 2 with respect to x3. And lastly, we have function 3 with respect to x1. I'm going to make this matrix slightly bigger. And then function 3 with respect to x2. And function 3 with respect to x3. So this is my 3 by 3 Jacobian matrix looks like. Now you can find this separately or straight away write it down in the given matrix form here. Okay, so let's try to do this. So let's find it one by one. Okay, let's find function 1 with respect to x1. Okay, look at this first function here. With respect to x1, I have this term. The first term here will give me 8x1. Okay, minus 15. Okay, respect to x1, and there's no more x1. Okay, nice. Now go to function f1 with respect to x2. Okay, I have this term here, respect to x2, that will be 2x2. No more. Okay, good. Now function f1 with respect to x3. I have 8. Okay, take the derivative of 8x3 with respect to x3 will give me 8. Okay, that's nice. Now move on to the second function. Respect to x1. Okay, let's see that. Okay, we have here. Okay, first this one. When I take the derivative, I will have 1 over 4 x2 squared x3. So 1 over 4 x2 squared x3. Okay, taking the derivative of x1. Okay, where else? Here, I will have 8x2 x3 plus 8x2 x3. Okay, that's it. That's respect to x1. Now, function f2 respect to x2. Okay, look at x2 here. 2. 2 times 1 over 4. That will give me half. 2 over 4 half. x1, x2, x3. Am I right? 2, bring it over here. That will be 2 over 4. x1, x2, x3. Okay. There's no x2 here, but there is x2 here. That will give me 8x1, x3. Okay. That's for my function 2 respect to x2. Now function 2 respect to x3. So I have here, I'm just going to read now. I have this here, this term, and this term. It's going to be, you've got to add all this term here. For this x3, you will have 1 over 4 x1, x2 squared. Okay. Now for this one, 3 times 2, that gives Okay, now this part here, what we have, let's do 8 times 2. No, I'm doing this one. Okay, 3 times 2, that will be 6. 6x3 squared. Okay, let's make it smaller. Look at that. So this is 3 times 2, 6. x3. Now you lose one power, which is 2. Okay, now this part here, respect to x3. I have 8x1, x2. Great, we have done the second function. Now we have to do the third function here. So what we have, first we have the third function with respect to x1. Okay, let's see that. We have x1. Where is my x1? I have two parts here. One is here. And the next one is here. Okay, so we have 6 times 2. That will be 12. x1, x3. Okay, the other variable, if you are not taking the derivative, it remains as a constant. Okay, I forgot to mention that. Okay, now minus. Cos gives you sine. So I have negative 3 sine. Okay, x1, x2. This is I'm doing like implicit differentiation here. Okay, I have take the derivative of cos, that give me sine, and the inside variable remain the same. But now when I take the derivative with respect to x1, will give me x2. Okay, I hope you get this right. Okay, now the third function with respect to x2. Okay, there's no x2 here, there's an x2 here. So take the derivative of x2 will give me 8x3 squared. Okay, this is done. Now this one, same case like what you did with the x1. So take the derivative of cos will give me negative 3 sine x1, x2. Now I am taking the derivative with respect to x2. That will give me x1. Okay, that's done the function of third function with respect to x2. Lastly, third function with respect to x3. Okay, so we have here. Okay, that will give me 6x2 squared. x1 squared, not x2. 6x1 squared. Okay, for this part. And this one, x3 squared. Okay, there's a power 2 here. So 2 times 8 will be 16. x2, x3. Am I correct? Okay, you will lose one power. That will give me x3. And then 2 times 8 is 16. x2, x3. Okay, and there is one more. Okay, done. Look at our Jacobian matrix here. It's a big function. Okay, all I gotta do is now put that in this matrix. We have x1, x2, x3. Let's do a big matrix here. The first part, this one. We have 8x1 minus 15. And then we have 2x2. And then we have 8. Okay, done. And then the second row, I have 1 over 4 x2 squared x3 plus 8 x2 x3. And then I have 1 over 2 x1 x2 x3 plus 8 x1 x3. Remember, this is a matrix, so you have to put a space because this is like, consider my second row with the second column here. Now the last one, 1 over 4 x1 x2 squared plus 6 x3 squared plus 8 x1 x2. Okay, now lastly we have the third function. I have 12 x1 x3 minus 3. I'm going to write x2 in the front. Sine x1 x2. Okay, and then I have look at that. I should have adjusted so that there's a space here. So just gonna write it slightly smaller because it's a matrix, so you have to be careful. 12 x1 x3 minus 3x2 sine x1 x2. Okay, much better. And then this part here will be ax3 squared minus x1 right in the front, 3x1 sine x1 x2. Okay, and then lastly this one, 6x1 squared plus 16x2 x3. Here you go. This is the Jacobian of the three-dimension system. That's a very big number here. Remember this is very important. Okay, this is very important when we want to solve a system of nonlinear equation. Okay, now sometimes there are also questions. So since I have slightly more time now, I'll show you one last example. How if you're given a function like this? Okay, example, find the Jacobian of this function. Okay, so it's given like this. Minus 15x sine y plus y squared. Okay, so you don't clearly see here how many functions. How do you write it in terms of f1 and f2, right? But we know that it has two variables, x and y. Okay, so we have a function respect to x, and we can have a function respect to y. So that's how you split this equation to a two-dimension system. Okay, so how do you do this? So split the to two dimensions. So I'm going to have a function f respect to x. What's the equation? And then the function f respect to y. Okay, so let's do this. To find the derivative with respect to x, I have 8x minus x over here, 15 sine y plus, okay, so I have 15 sine y, and then there is no more x here. So this is my first function with respect to x. Okay, now the second function with respect to y, I don't have here, but I have it here. Sine y will give me cos y, negative 15x cos y. And then y squared gives me 2y. Okay, so now make your calculation more easier, because I already have this. You can write this as your you can slightly, instead of writing f1 and f2, I can write this is my fx, this is my fy. So my Jacobian now will be first fx with respect to x, and then the second one will be fx with respect to y. See that? Because we have x and y. And then this part here will be the function of y with respect to x, and the function of y with respect to y. That's how you do it. Okay? That's how you do it. Okay, I'm gonna leave this as your homework. Okay, if you manage to find, just leave your answer in the comment. Okay, just write the Jacobian for this function in the comment, or email me if you can. Okay, so I just want to say that the above Jacobian can also known have Hessian. Okay, I'm just going to write this new term for you to just study and find out more. Okay, so that's all for today's session. So I've given an introduction how to find the Jacobian matrix. So on my next video, you will see how to use this Jacobian matrix or to solve nonlinear system. together with Newton lump sum method. Okay, that's all. Bye for now.